Here we go. All right, folks, let's bring it in. Here we go. Newton's third law. Talked about it briefly last week. In junior high, you learned it as for every action there is an opposite and equal reaction. I'm going to give you a little more verbose of an explanation. Newton's third law. If object A exerts a force on object B, then object B simultaneously exerts. If object A exerts a force on object B, then object B simultaneously exerts an equal force back on object A in the opposite direction. Woo! Okay. If object A exerts a force on object B, then object B simultaneously exerts an equal force back on object A in the opposite direction.
Like normal force?
Could be a normal force. Could be a lot of different things. If object A exerts a force on object B, then object B simultaneously exerts an equal force back on object A in the opposite direction. Okay, we're going to unpack that today. Good with that? Okay, quick examples. If you kick a ball, your foot exerts a force on the ball. Newton's third law says the ball simultaneously exerts an equal force back on your foot. Now you might think that's stupid. The foot's the one exerting the force, the ball is just the victim. Okay? Have you ever tried to kick a ball but miss? Did you know it? Yeah, because your foot's like, whoa! Like you're totally anticipating your foot to experience some resistance, a force, if you will, from the ball on your foot. You okay with that? Okay. You're pushing a refrigerator, it's pushing back on you, even if it's not moving. If the refrigerator would all of a sudden disappear, you'd be like, whoop! You're expecting that force back.
Like your
Okay.
guys removed from the timeline?
Yeah, something like that. Okay, so this one's crazy. There's a force of gravity on a raindrop, anything falling really. The object that causes that force is the earth. Okay, so Newton's third law says there is a force of gravity on the earth from the raindrop acting up. What? Huh? Okay, there's a force of gravity pulling the two together. Okay? So if I jump, gravity is grabbing hold of me and pulling me down. I'm experiencing an acceleration of 9.8 meters per second squared downward. Yes? Okay? Is the Earth experiencing an acceleration of 9.8 meters per second squared upward? Pretty sure the answer is no. Why not?
Because the mass is too much?
Because the mass of the Earth is so much bigger than the mass of me. So we respond differently to the force based upon how much inertia there is. You okay with that? But we do experience equal forces. Okay? Alright. So, some characteristics of Newton's third law, just some details that are wrapped into what I just gave you. They always have the same magnitude, same strength. They always act in the opposite direction. They always act simultaneously. It's not a cause and effect. It's like happens at the same time. They always act on different objects. There's an object A and an object B. And because of that, these forces don't cancel each other out. This is the only point in here that wasn't wrapped up, wasn't described in that green explanation I wrote out, okay? So they don't cancel out because they always act on different objects. A force acting on one object cannot cancel out another force acting on a separate object. The only forces that are acting on the same object can cancel each other out. You okay with that? So those are just some factoids. Very good. Tell your neighbor. Okay, what do you say? You got votes for D, dangerous dinosaurs is correct. Newton's third law is the reason for that. Okay, everybody good? Okay. So, question. Thumbs up if you got a guess. Tell your neighbor. Everybody good with D? several D's because they're acting on different objects. You got an object A, object B, okay? So if we were to draw, if we were to draw the 3-body diagrams of these guys, okay? What we would see is you have force gravity, normal force, applied force. Okay, I'm going to jump over to the yellow one. It has less gravity, therefore less normal force. Is there applied force going to the right? Are you physically touching the yellow block? No. So what this is actually a normal force on B, block B from A. A also has to experience that same force because of Newton's third law, normal force on A from B in the opposite direction. These two are Newton's third law force pairs. They do not cancel each other out because they're acting on different objects. These two forces cancel each other out because they're acting on the same object. Okay? But these do not represent Newton's third law because they cancel each other out. They're acting on the same object. Okay? These do. No? Tell your neighbor.
C.
Correct answer is
C.
C. Everybody's getting a theme here. Okay, same scenario, different question.
Bringing forward nice answer.
Hey, let's not split.
Certain things. No, it doesn't. Haley, no make her try.
That's wrong.
Wait a second. Oh,
Yeah.
Tell your neighbor why you think so.
Hey,
This is fun. You know, we're reading like today. Oh, you should do that.
Yeah?
Yeah.
I like to usually like to see it. Alright, correct answer is, I got one vote for A. I got a D and a B. I got 2 votes for A. I got 2 votes for C. You know, we got alphabet soup. Alright, so, are we good with the fact that both objects experience the same force? Previous question, okay? This guy has a lot less mass, therefore it's going to have a greater acceleration than the dump truck that has a lot of inertia. Therefore, it does not respond that much to that force. You right with that?
So which answer is right?
Correct answer is A. The Volkswagen Bug has a much greater acceleration because it has less mass. You right with that? It responds. They both experience the same force, but they respond differently to the force based upon how much mass there is.
Like, because
Okay.
they're going at the same speed.
They don't even have to be going at the same speed. Okay, now, when I was in your shoes, I figured out what the right answer was. It's just same force, Newton's third law. I didn't really believe it though. Okay, until I saw this demonstration. Okay, so here's our Mack truck. And here's our Volkswagen Bug. Okay, they have a force probe on there. And what I'm going to do is I'm going to go through a series of different collisions and scenarios. So I'm going to crash the dump truck into the Volkswagen Bug. I'm going to crash the Volkswagen Bug into the dump truck. I'm going to do a head-on collision. I'm going to push with the Bug, push with the truck, and push, do any and every combination. And we're going to measure the forces acting on both of them. Okay? So we're crashing the Bug, crashing the truck, doing a head-on collision, boom. Oh dear. We're going to push, we're going to push, we're going to push. Oh Lord. Okay? This was because the weights fell on the force probe. Ignore that one. Okay? But every collision, they happen, same force, happens simultaneously. It's not a cause and effect. It's like a together. They experience the same force for the same amount of time. Always. Regardless.
Basically,
Okay. Hold on, Vincent. Okay. Does that make sense? For me, that like sealed the deal. I'm like, oh, it's not just just crazy talk from this teacher guy. Okay, good with that? Okay, Newton's third law, it's a thing. All right, we've got a pre-quiz tomorrow. Pre-quiz tomorrow. Due tomorrow.
really?